Hi, my name's Simon Lamb. I'm a technical evangelist with the Melbourne team at Microsoft. So today we're going to be talking about gaming experiences and particularly cloud-powered gaming and what that kind of means to us. As a technical evangelist, usually I'm kind of working with partners, and I work with ISVs, helping them deliver and create value on the Azure platform. I probably threw away about 6 to 7 years of my life as a raid leader, running a guild on Warcraft. So I think I'm uniquely certified to give a talk at a gaming convention. But yeah, it's probably 6 years I'll never get back. So.
I'm Christian Costano. I'm the lead online programmer here at Azure Interactive in Copenhagen. So Hitman is about Agent 47. He's a world's deadliest assassin. You know him as being the bald guy with the red tie in the suit. We are game developers. It was important to us that we had a platform on which we could focus on the game and not the infrastructure. And Azure was a natural choice for that, as it provided a platform as a service from the get-go. We use a lot of different services on Azure, so it's hard to pick one as a favorite. But App Insight is one of those that we could integrate very easily with and provide us some kind of transversal monitoring on our systems.
I've been working with the Azure Interactive for the last 3 years or so with this title, and the game and the cloud platform is moving really fast, and it has been really helpful to be there with them and help them in a partnership to develop the game.
So my favorite feature in this game, which is absolutely dependent on the way we built it, are the game's elusive targets. These are time-limited missions, basically the closest we could get to making you, the player, into Agent 47. The fact that we had a platform that allowed us to create these game experiences and then deliver them to players in a way that counted. If you missed that shot, you hit the wrong target. If you missed your time window, you could never play it again. And being able to create that experience was only possible because of the way we built this game.
So even worse than putting a video straight at the start of a PowerPoint is to put on auto start, so then I couldn't even give you any context. So I kind of like that video because they're talking about some stuff that I think is really cool, and that's one Azure. But two is the amount of services, like the platform as a service, stuff that you can go and leverage on there. But most of all, application insights, because of that kind of live ops kind of monetization aspect where you can go and you can not only go and look at potential kind of problems and for your kind of application performance management, but also go and actually target specific parts of your game that are going to help you monetize. So what are cloud-powered games? So I think we've kind of nailed application development from a point of view that we're not building bridges, right? When you go and build a bridge, we do it the same way every time. It doesn't change. Whereas if we're building an application where something's changing several times within the actual development, and two, being able to kind of adapt and deliver small chunks, and keeping people retained by sending out more and more content. On top of the fact that with cloud, we don't have to go and manage that infrastructure. So, particularly with Azure, with everything's focused on platform as a service, we'll go and manage that stuff for you, and you can just go and use that and concentrate on actually building your games. And how do you build one? Well, that's the other cool thing about the kind of Microsoft ecosystem. It doesn't matter whether you're going to be using Unity, .NET, Ruby. It's actually pretty amazing. The amount of stuff is. I think it's our tagline. Any developer, any platform, any language. So, games not the same today. So I guess, and we kind of started to see that with something like Warcraft, right? Where you had that, we had that retainment where people were just playing for 6 years, and we look at things like your GTA Online, like those guys were think they were recently an article where they said we didn't even think it'd last this long, and so games are really focusing on the massive scale and retaining those people as long by continuously bringing out content. So we retain those users as long as possible. And as a DevOps guy, it's all about how I can build stuff, how I can create that value, but more importantly, how I can deliver that value as quickly as possible. Because if I don't have to build an entire game and box it up and then ship it out and advertise it, and I can just get out a small part and then continually deliver that content, I can start earning money as soon as possible, and then retaining those people as long as possible. I can go and use the services that Azure has to go and get that out, globally. And then I can go and use those kind of live ops services to go and get that telemetry and go and adapt to what everyone's doing. So I guess the way in which we kind of build games, in which we build software. As I said, we used to go and build software and we put it in a box, and we go and deliver that out and put it out in stores. And now we can go and use services to go and get that out to people as quick as possible, and we can get those continual purchases. So I think one of the reasons I put that video up at the start is because one of the developers from was saying, well, that's why they chose Azure, because their ability to go and get that massive scale, go and get that performance, and use all their services that would cost them heaps of money to go and build themselves. So why Azure? So I love the line that Azure has. And by the way, I've said Azure my entire life, right? But I've been working for Microsoft for about 6 months, and I'm now indoctrinated, and I can't help it but say Azure. So I'm sorry. Azure. We've got more data centers than AWS and Google Cloud combined. That's one of the big kind of selling points, and that becomes especially important when you start looking about the intelligent edge, and looking at things like Cosmos DB, where we're providing data sources where you can go and kind of read from a local data center and write back to that local data center for maximum performance for users. But then we'll go and synchronize it to the other data centers for other people to go and read in other places around the globe. So that's really important when you're talking about games. You're talking about just getting the maximum performance for your users. And particularly when we're looking at these, the scale of some of these games, we're talking about 500,000 concurrent users that are playing these games at once. That's really important. And then it's really hot in here. And then we've got abilities to go and do things like hybrid deployments, where you can go and put stuff in your own data center. You can go and put and kind of extend that out into our cloud. Obviously, and there's a big focus on OSS. So in this whole one platform, any platform, any technology, Microsoft's made a massive investment in OSS, and you can see that if you go and build software and you go and use something like Visual Studio Team Services, which I use a lot. If you go create a new build in there, the first 15 things aren't even Microsoft anymore. It's everything like Grunt and Gradle and Maven. There's a massive investment in just other people's technology, including OSS. I guess the other important thing is reliability. So depending on what your kind of technology choice is, whether it's like VMs, containers, Service Fabric, whatever, there's a massive amount of kind of scalability options to go and make sure that your game is available all the time. Oh, there we go. Here's my number. So, yeah, I thought CCU was cloud compute units, but concurrent users, all good. So, and yeah, it doesn't matter whether you're like a big gaming house and you're going to go and use like Azure rendering engines and use existing continuous integration pipelines, or whether you're just an indie developer and you're just creating some game in Unity or in Visual Studio. Microsoft's pretty much got you covered. So, and I guess so that we're talking about from dev toolset and CI/CD pipelines. Is it who used writing games and using using continuous integration? All right, nice. And so what are you using to do those like CI pipelines?
I didn't set them up, so I'm not actually going to pipeline. We use some stuff like JetBrains.
Oh, like TeamCity.
Yeah, TeamCity.
Yeah.
Yeah,
nice. Yeah, I used to use TeamCity when I played Warcraft. So that's really cool that we can start bringing those kind of first-class strategies that we're using in normal app development into game development. And I think it's really important when you want to. Do you do kind of unit testing with games?
Yeah, we do. The coverage is not great. We have like 4% coverage in our game.
Yeah.
Of Vampire games, but I would test what we can.
Yeah.
Testing games hard because there's a lot of visual aspects which are important.
Yeah, sure. But particularly when you're building kind of cloud-powered games as well, you're going to have a lot of back-end services and stuff, and that's the kind of stuff you can really go and test well with unit tests and integration tests. So yeah, getting those now pretty common patterns and applying games is fantastic. We're going to look a little bit later at the kind of cloud rendering options, the batch rendering in Azure and what that kind of means, and that kind of rolls into physics as a service, which is that cool stuff in Azure, which kind of I think originally kind of came out with Titanfall to allow you to go and get a game, and when it's on like a low bandwidth, when it's showing video, and it kind of does really cool stuff, or it'll kind of make where you're looking, where the focus area look really cool, but the rest is just looking like rubbish. But it's doing that in order to make sure your experience is really good. Yeah, so I guess this is this like kind of scenario. So whether you're a big gaming house and you're going to use batch rendering services, you're going to use those existing CI/CD pipelines, or whether you just want to write on Unity and you just want to, you're not going to go and capture all this telemetry from people. You're just going to write that, deliver that out, and then just use something like Mixer to just have that kind of personal interaction with your user base. So what are your options? So on Azure, it's like, it doesn't matter whether you're building for Android or Apple or Xbox. There's a whole lot of partners already on there that can come and help you, and there's a whole lot of kind of PaaS services and like kind of the equivalent of appliances to help you go and create that content. And then the actual lower level kind of services on Azure that you would actually go and use. So whether or not the ones kind of over there on the left showing the types of apps you're building, whether it's VMs, containers, service fabric, and then you go and look where I'm going to store my data. So you can go traditional SQL, use kind of document DB, which is now Cosmos DB, and then go and get those insights. Whether that's whether you're going using cognitive services to go and do object image recognition and analyzing people's text, analyzing their reaction, getting the kind of user insights, or going real gangster and start using like machine learning to go like do things like churn analysis. We'll look at one of those kind of models a little bit later. And then you're going to go visualize that stuff. So we're going to go grab those insights, but how do we go and visualize them? We're going to use something like Power BI to go and show you as a company or as a game developer what those insights are. So yeah, there's the any technology, any language slide, and I think that's pretty cool. There's let's talk about what are people actually using to develop games. Unity, hands up. Yeah, all right, cool. All right, there's others as well. So, building up for cloud gaming. So, yeah, if you're going to go and build this stuff on a VM, that's probably your simplest. It's the simplest option. That's why guys like AWS have massive that massive position in cloud computing is because everyone had boxes in their data centers at the office, and they needed to go and move them somewhere, and they needed to move up to the cloud, and those data centers took that lift and shift really well. Microsoft's focused on a kind of platform as a service play, and that's really the kind of next step where everyone's moving to now, because they don't want to manage those boxes. They don't want to, even though they're in a data center somewhere, you've still got to go and run all the updates. Still got to go and update to the next version of the operating system. So platform as a service says, hey, don't you worry about that. I'll abstract that off, and you can just worry about building your content. So then the kind of next, or then another logical step was going to containers. So if I want to go and take those kind of microservices, and I want to get that separation of concerns, and so my teams can concurrently go and work on things. We're just going to put them in individual containers. So, and then we can do some pretty cool things like, use orchestrators like Kubernetes to go and enable us to both manage and scale those. And then we're going to look at things like Service Fabric. So if I really want to take those microservices and put them in kind of self-healing kind of worlds where I can scale that up stuff really fast, use kind of active patterns, and then if things, the framework gives you the ability to say, well, if something goes wrong, it'll just go and bring itself back up. And we'll show a video a little bit later about I think it was like Age of Ascent, one of those kind of big flagship game that they would build on Service Fabric. So the PaaS services specifically, most of the time if you're building a web app, you'll be building on an app service. App services, we've got them in the standard flavor, we've got them in app services for Linux, which you can put a container behind if you want to. And then we've got things like for massive scale app service environments, which allow you to go and kind of create these in the same kind of way as like in a similar way to containers. You would go and create a set of agents and say, well, hey, I need to be able to scale this thing up to this level, and give it parameters from which when it should scale, and in order to handle those massive amounts of load. But then we've got serverless architecture, so we can go and look at things like Azure Functions, it's similar to like AWS Lambdas, and in which you can say, well, hey, I need infinite scale, and I don't want to have to pay for it when it's doing donuts. So those are the Azure Functions. You can go and put those bits of logic in there, and it will it'll go and scale those up when it needs to, and you'll only pay for them when they're executing. And there's this other thing of like logic apps. I don't think you'd actually build an app in a logic app, but that's challenge accepted. But it's more about, well, when I'm going to go do those things, like say for are you building like a leaderboard or something, and you need to go and run a function that goes and does that. You can go and put that in a Logic app, and in the same way as an Azure function, which is a bit of a nicer way to build, a more visual way to build it. You can go host that there. And then for the non-developers, so I guess I jokingly say, well, maybe that's when the CTO wants to have a go at developing. You can go and build on a Power App. But the cool thing about Power Apps is that you can also go and deploy that out to phones and multiple, a lot of different devices, and it will go and handle that for you. So storage devices, or storage options. So, and the cool thing about Azure too in regards to storage is that if you go and put it in a blob, you can go and access that from multiple places. Like if you want to go and pull that from an Azure function, you could go and use Stream Analytics to go and look at a blob and go and analyze that and put it through machine learning patterns. Like once it's in there, your options are just like not limitless, but substantial. So we're talking about blobs, tables. If you want to go and use Azure Tables, I'm pretty sure Azure Tables are underpinned by Cosmos DB now. Or is that a lie, brother? Yeah. So yeah, I'm pretty sure that Azure Tables they're now. So if you want to do really quick data access, I'm pretty sure they're underpinned now by Cosmos DB, which which gives them the ability for them to go and, as I said, run close to the edge where you're accessing it from, and then you can go and look at things like for getting that ability to kind of queue off and take the load off the thing that's processing it. You're going to use things like Service Bus queues and Azure queues. Yeah, my video. So yeah, this video is a little bit old, but I think it's kind of it was looking at a service fabric when they were using it to do age of ascent, and it was kind of like it's pretty much analogous to like an actor pattern where they've got all these ships, like a massive amount of ships, and they want to go and deliver it out to things like a web browser, and they don't want it to run like a dog. So just have a look at that.
A game of such massive scale that's never been created before.
We really wanted it to run naturally in the browsers. Anyone can play it immediately, whether it's your laptop or your phone or your PC.
We were building a system that could cope with huge demand and huge concurrency, huge availability. Around about the same time Service Fabric came about.
Say two alliances suddenly decide to go to war on a whim. They all meet in space at the same time to duke it out.
Our microservices in Azure Service Fabric will automatically scale up, begin unfolding space, and seamlessly distribute the load across all the nodes in the system.
We've tested it up to 50,000 concurrent players in the same battle arena. We were handling 267 million application messages a second.
Our game microservices are built using ASP.NET Core. It gives us superior performance. ASP.NET Core is open source. That allows us to contribute back to it if we have any performance issues, which then Microsoft review, and together we make a better product. Our contributions to Kestrel have reduced allocations, lowered latencies, and allowed it to be already 2,300% faster than previous incarnations of ASP.NET and more than 6 times faster than Node.js.
We run public player versus player alpha playtests once a month where anyone can just drop in. All you need is a modern browser that runs WebGL, turn up at the website, and you can play the game against other players around the world.
Look how many claims that their microservices like spin up and unfold space. Like, wow. So yeah, so whether or not your choice is Unity, and when you guys do you use like Visual Studio and stuff connected to debug? Yeah. And I guess when you're going using Visual Studio as well, then you've got access to a bigger platform, which you want to go and use. And where do we code? Where do we code? What kind of code repository? Yeah, that's it. I'm not going to stop you. Okay. You can go to say Visual Studio Team Services. Sorry, yeah. Or Vistas. No one calls it that. So we're using that. Listen to him for the name. But we were previously using a paid service, which we were pretty happy with. We were just trying to clean in these because some of them all about various online stuff. So we tried out that because it was free to turn it on. It took us like an hour to our repository of it, and it was downloading like 10 times faster. So all my teammates had in the repository seeing out the URL. Click here to make yourself log in. So it's very cool. But yeah, that's all about project repositories, the whole thing. It's, I think, 4.5 years ago, so it's enormous. Yep. Okay, and so what about CI? So you don't do any. So when you're checking, you don't do any kind of building. Sorry? Do you do any CI? Like, no, at this stage, because it's a really small program, only 2 of us on it. Yeah, okay. Most of that stuff is Unity and related stuff. So and R. Oh, okay. Yeah. So yeah, there's I think now there's a couple of thousand code files in there, which are just the C# Studio. Yeah, cool. That's already taken over there. Yeah, it is just easy to check in your yeah. So we work really well together. Yeah. So we. I think it's awesome to be able to go and put like debug points in and use Visual Studio and be able to leverage all those other kind of services that are available. Mixed reality. So I don't know if you were just in here for Rocky's session. It's hard to follow Rocky, but so Microsoft's made a pretty big investment in mixed reality, and there's a whole lot of different devices at different kind of price points. So whether or not you pay a lot of money for the HoloLens or that new Samsung device, or down to some of the other devices that are a lot cheaper. If you're thinking about mixed reality and you're excited about it, surely hook you up with Rocky, who is the man. But I guess the main point here is that Microsoft's investment is about building that code once and going and delivering it across all those devices. So they want to go and use UWP and yeah, nice. I think they're free though. It's like it'd be like Oprah Winfrey. Everyone look under your seat. But yeah, so I guess the investment is all about like I said, writing that code once and being able to go and deploy that to multiple platforms. So whether or not that's a UWP device or out to phones or a Windows tablet. I had this app in this UWP app called Social Dribble, and it was like Trickle. It was a Twitter app that would just do a one tweet feed. And I'm so want to go and run that on a HoloLens. I reckon it'd be really cool just to kind of be looking and just kind of put that one tweet feed out there to go down. So yeah, Visual Studio Team Services. It's I think obviously I've been drinking the Kool-Aid but I think it's uniquely positioned, probably to be one of the very few platforms on Earth that can. I shouldn't lead so hard. To be able to handle your entire kind of CI/CD and kind of a good majority of your ALM process, right? So, like I said, the code repository is amazing, and if you're on GitHub and you get, I think you're one private repository, VSTS, you can spin one of those up. It's 5 users for free. You don't have to pay anything, and that's unlimited private repositories. Just go for it, right? So the two repositories, it's got a standard TFS repository and Git. Yeah. Right. Yeah, my first response to that question is I don't know, but I'm pretty sure it's no. Yeah.
Well, we locally host our material things. We have a 60 gig web server repository. We just have a web server sitting in. It's easy to host our material. But yeah, I don't know.
I guess the cool thing about this is becoming a VSTS sell job, I'm pretty excited about it. So it's not hard. But VSTS since it's a total SaaS platform, it's updated like every 3 weeks. Like that's the kind of sprint they run, or the VSTS team. So it's actually pretty cool to demo it sometimes because I've gone to maybe do a 3-day thing, and I'll go demo something one day, and then I'll walk back in the next day, and the buttons moved. You know what I'm saying? So it's usually those things are they're kind of handled by things like feature toggles, where they've gone, they said, we've got a new experience. Do you want to have a crack at that? And if you say yes, it'll change to that view. But then you can always go to your preview features and say, well, hey, I want to turn that thing on or off. So they're pretty good at using kind of dark launching techniques and stuff to go dark logic, like feature toggling techniques to allow you to go and play around with those new features. But it's really extensible, right? So if you were to go and run, you want to go and run something like a local code repository, but you wanted to go and start doing the builds in there, you can pretty much anything you could do with a PowerShell script. You can go and do that in the build or in the release, and go create some pretty complex kind of release pipelines. So you go get it out to early adopters, and then they can play with it, and then move it through that pipeline to finally through to production.
You do like automated submission to updates to the Windows Store and stuff like
Yeah,
that?
and they would go through something like Mobile Center. Mobile Center is another.
I use Mobile Center. I didn't realize that's for submitting to the Windows Store.
Well, you can definitely go out through. You can go through like the iOS store with what's that? What's the submission thing? Let me check on that. I'm pretty sure. Like it'd still have to go through a submission. Like yeah. I shouldn't say yes straight away without actually knowing. So I'll go and check on that. Get back to you. So you create these really extensive kind of build processes that you pretty much do anything in there you want to do. But there's also this massive marketplace for going grabbing build tasks that people have already done. So if you're going building Maven, like a Java game, you can go and use the build tasks that are already in there, or if you're going using Team City to go and do your building, you can go up to the marketplace, grab the Team City build tasks and bring them into your flow, and then it will give you this kind of first class experience for how you will say, well, hey, these are the things you have to go and tell us for us to go and do this build, and we'll go and do that. Testing. The other cool thing about being in the cloud is if you're going to go and do testing, you can if you want to go and do unit tests, that's you can do that at the time of build, or if you want to go and do kind of integration tests or kind of coded UI tests, or even like a load tests, we can do that up in VSTS. So you can go and spin up basically kind of bot armies to go and really go and test that load, and you make sure you're satisfying your kind of performance metrics. And then obviously the deployment aspect. What are you deploying to, like, for typically for when you're doing game development? Yeah. Is it? Oh, nice. Is anyone doing any writing cloud-powered games like that are actually being deployed out? I probably should ask that at the start.
We use cloud, our cloud service that we make built on Azure to store all the cloud saves.
Yep.
For Microsoft have cloud saves.
Yeah. Yeah. Also, like they started to make DevOps really easy. It's like we can go use our continuous delivery extension to go. It's kind of making me pointless. Like, you can go one click to win. But yeah, so thanks, mate. So the batch rendering, Azure batch rendering. I don't know a huge amount about Azure batch rendering, but we were about to see a video in which I was saying that the result I know about, and that's being able to go and say, well, hey, I admit that there's going to be like low bandwidth kind of users, and how do I kind of deal with that? That's probably physics as a service, not Azure batch rendering. But Azure batch rendering lets you kind of offload those rendering tasks, and probably for kind of bigger development houses, so you can go and give that to the cloud to go and create to render those assets, and you only pay for what you use. And there's been this massive, I'll go back, investment in a whole lot of VMs where I think there's some numbers on here. No. Where they've just got all these massive amounts of NVIDIAs with GPUs for going and actually doing those rendering tasks. We'll probably also use them for all the data science stuff as well.
Do you know roughly how easy that is to set up? Like, we don't frequently render stuff. Sometimes we do, when we do, it's like half a day to render whatever might be rendering for screenshots or something. But yeah, so like, is that like a plugin for Maya or previous maps and render in cloud?
I'll probably have to connect you with someone to get the answer there. Yeah. So here's that. Oh, let's go back. Sorry. We talk. This kind of rolls into physics as a service, and that's what we're talking about, like kind of low bandwidth, presentation of video. And the cool thing is that the service can actually do to kind of make that experience better. So as I was saying before, it goes performs tricks to be able to kind of focus on the actual where it knows your focal point will be, and whereas around the sides you optimize those as well, and you'll see that in the demo. So let's just play a little video.
hopefully will come out one day.
Yes.
Is that using a particular physics API like Possess, or is that like agnostic?
So I guess once again that focus of whether or not you're a massive game development house and you're going using those existing leveraging those existing services, and whether you want to go and use batch rendering to go and do that rendering, or you can choose to use that. Otherwise, there's like pay as you go options. So if you want to go and have a play with that, and we find out that it's super easy, then you can go do that and just pay on a credit card. Let's get off that one. So, as I said, we've got more data centers than anyone, and that enables us to do tricky things with Cosmos DB and getting you to be closer to the edge. I think there's a couple more announced in Australia, in Canberra, and and there's some other kind of availability zones and stuff coming to the existing data centers. And then we could do, and then we have this amazing kind of abilities with things like the traffic manager, like the load balancer, to get us to enable us to go and intelligently route people around to the right data center. That point there, sorry, that last one, oh really? Come on. That A/B testing point. So being able to, if you've got like kind of back-end services, or you've got some kind of cloud-based application where you can go and say, well, hey, I want to go and maybe dark launch some new features into one of them, and you can go and use the traffic manager to go and say put 20% of the people to one set of services, or you might say, well, I want all the people in Tasmania to go to one service, and you can go and use that to go and test that and validate that new service that you put up there is actually going to be able to handle either the load or those features are going to be applicable to the users. So I'm going to skip past that one. So autoscale. So if you're going to use virtual machines, there's not a super amount of ability to scale them beyond up, right? So if you go and run something on a virtual machine, you can go and spin it up. If you think performance degradation, you can go and make that machine bigger, but that's about it, right? And we can actually do things to go and enable you to auto scale that. But when you can start using things like VM scale sets and to go and put parameters in place to say, well, hey, when the CPU is tanking out at like 90%, then I'll need you to go and bring on more VMs to go and help handle that load, so we can go and handle that automatically. As you can see, there's the slider-based mechanism. It's that easy. But then you can go and use things like containers to, if you've really kind of architected your application to be more like microservices and got that separation of concerns, you can go and put those things on containers, and we'll go and things like Kubernetes as an orchestrator can go and scale that out for you. So, sorry. So, this is about Cosmos DB, and this is about that concept of the intelligent edge. So, where we want it to be as fast as possible, and there's, what's the number, Dave, on reads? Something like sub. Yeah, okay. So yeah, 10 millisecond reads on Cosmos, which is pretty amazing, and they do that by bringing that data closer to you, because if you're in the data center in US West, it's obviously going to be good for them, but no one else around the world. And if you're going creating a global game, things like Cosmos can enable you to transparently make things faster for your users based on their locality, but then it will go and do all the synchronization in the back end. And
Synchronization like something that's kind of real time, or is it like multiple second minutes? Alright, so it's pretty much instantaneous synchronization. It's not like just synchronization step every minute.
And there's other things about Cosmos in regards to like consistency options, like, so you don't have to go. You can have like eventual consistency, like where you'd be like, where it's maybe not important for it to be like a full ACID transaction. Like you don't have to block things waiting for something to happen. It will just you say, well, eventually it'll be right. So this is, I guess, it's another one of those scenarios where they say, well, hey, I can, as a big house, I want to go and deploy into all these different data centers, and I want to go and use things like the traffic manager to go and route around to the right data center, or hey, I might just go and use, might just go as an indie developer, go and have one VM, or maybe even just a few, and just use Scala sets to be able to go and scale it up. You've got a substantial amount of options that are going to suit your price point. I don't know a huge amount about Mixer, so I'm probably going to wrap that up there. So hopefully I've kind of showed you there's the options are there for on Azure. Yeah.
Do you know anyone Microsoft developer or something like that?
I can definitely sort you out. Yeah.
I have a lot of questions about that.
Yeah. Yeah. Well, I guess this next slide that plays into my point again about options, right? It's like, you can go and be capturing all this telemetry and going all this information, and you can be going through like really complex machine learning models that look like that. It's probably not even that complex, but it just looks complex to me. You can go doing things. You can go do some amazing stuff with using data science concepts to go and analyze that data. Or that's one end of the spectrum. The other end, you can go and write a game, and you can just go and use something like Mixer or Twitch or something to go and just interact at a more kind of personal level, and let them obviously interact within their ecosystem. So I guess so we'll have to talk about. You've got about 4 questions now, though. I can remember the last one. Definitely shows you the scope in Azure, depending on whether you're all the way from just a 2-man team, all the way up to a massive gaming house using batch rendering and with all their own CI/CD pipelines in place. But there's definitely some pretty cool options on Azure. Awesome, thank you so much.
first thing you suggested is literally what we're doing. Survival games. Sorry,
No, that's it. Oh, we didn't have that in Warcraft. That's cool. Now, thank you very much, guys. Hope you